Hello everyone, welcome back to my channel. Today we will be solving one of the cleanest and the most beautiful expression in mathematics, the infinite nested radicals. Don't worry, I will break it down step by step, so even if you are new to this, you will understand it perfectly. So if you observe this question perfectly well, you notice that this expression keeps on repeating itself. Like you have 20 plus square root of 20 plus square root of 20 plus dot 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 means it keeps on repeating forever without an end. So the next thing we are going to do is that because this keeps on repeating itself forever, then I can rewrite this equation as the square root of 20. This I can write as x because it keeps on repeating forever, right? Because if I should elongate this equation now, simply means I can write this as square root of 20 plus square root of 20. It keeps on going, but we don't want that, right? So it's better for us to write this as dot 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 because it keeps on repeating itself. Then I can just replace it as x because it's still the same thing, right? So we have x equals to square root of 20 plus x. So the next thing you want to do right here is you have to take the square of both sides. Taking the square of both sides, you have x squared equals to square root of 20 plus x all squared. So we have x squared equals to square can cancel out the square root over here. You have 20 plus x. Now, what we want to do here is that you can transfer this, anything here, to the left hand side. So you can have x squared minus x, because if positive x goes over to this left hand side, it becomes negative x minus 20 equals to 0. Now this is a simple quadratic equation of which we can use different methods to solve, but I would like to use the almighty formula. The almighty formula is x equals to minus b plus or minus the square root of b squared minus 4ac over 2a. Now don't forget, the general equation of the quadratic equation is ax squared plus bx plus c equals to 0. So now we have to compare these two equations over here. Now, it's safe to assume that a is equal to 1, b is equal to minus 1, and c, which is a constant, is equal to minus 20. Right? So from here, you can say x equals to minus b. Our b is minus 1, so it will be minus 1 plus or minus the square root of b squared minus 1 squared minus 4. A is equal to 1. C is equal to minus 20 over 2a. 2 multiplied by 1. So from there, you can say x equals to minus 1 is positive 1. So I write 1 plus or minus the square root of minus 1 squared. Minus 1 squared is 1. Then we have minus 4 multiplied by 1 multiplied by minus 20, which is simply positive 80. All over 2 multiplied by 1 is 2. Then we have x equals to 1 plus or minus 1 plus 80 is 81. The square root of 81 is 9 over 2. Now because of this plus or minus, we are going to have two values for x. So we have x1 is equal to 1 plus 9 over 2, or x2 will be equal to 1 minus 9 over 2. And x1 is 1 plus 9 is 10 over 2, or x2 is equal to 1 minus 9, which is minus 8 over 2. And x1 is equal to 5, or x2 equals to minus 4. But don't forget, we are dealing with a square root over here, right? And in a square root, there is no way you can have a negative answer. Negative answer in this case means it's an extraneous solution. So x equals to 5 is the real solution for this problem. Now let's check. If x is equals to 5, then we have square root of 20 plus x, which is also 5. We have 5 plus 20 plus 5 is 25. Square root of 25 is 5. So 5 equals to 5. But the question you should have to ask yourself is, why did we use minus 4? If you are checking this, let's say minus 4 equals to square root of 20 minus 4. Minus 4 equals to 20 minus 4 is 16. Square root of 16 is 4. Minus 4 is not equals to 4. So this automatically means x equals to minus 4 is an extraneous solution. So that's it. The value of the infinite nested radical is equals to 5. If you like this explanation, kindly like, subscribe, and comment if you want me to solve more math problems like this. Thank you for watching. See you in the next video. Amen.